This artist's concept depicts a supermassive black hole at the center of a. The blue color here represents radiation pouring out from material very close to the black hole. The grayish structure surrounding the black hole, called a torus, is made up of gas and dust. Credit NASA. Caltech. Young galaxies blaze with bright new stars forming at a rapid rate, but star formation eventually shuts down as A evolves. A new study, published January 1, 2018, in Nature, shows that the mass of the black hole in the center of the determines how soon this quenching of star formation occurs. Every massive has a central supermassive black hole, more than 1 million times more massive than the Sun, revealing its presence through its gravitational effects on these stars and sometimes powering the energetic radiation from an active galactic nucleus AGN. The energy pouring into from an active galactic nucleus is thought to turn off star formation by heating and dispeaking the gas that would otherwise condense into stars as it cooled. This idea has been around for decades, and astrophysicists have found that simulations of evolution must incorporate feedback from the black hole in order to reproduce the observed properties of galaxies. But observational evidence of a connection between supermassive black holes and star formation has been lacking, until now. We've been dialing in the feedback to make the simulations work out, without really knowing how it happens, said Gene Brody, professor of astronomy and astrophysics at UC Santa Cruz and a co-author of the paper. This is the first direct observational evidence where we can see the effect of the black hole on the star formation history of the. The new results reveal a continuous interplay between black hole activity and star formation throughout as life, affecting every generation of stars formed as the evolves. Led by first author Ignacio Marta-Navarro, a postdoctoral researcher at UC Santa Cruz, the study focused on massive galaxies for which the mass of the central black hole had been measured in previous studies by analyzing the motions of stars near the center of the. To determine the star formation histories of the galaxies, Marta-Navarro analyzed detailed spectra of the light obtained by the Hobby-Abele Telescope Massive Galaxy Survey. Spectroscopy enables astronomers to separate and measure the different wavelengths of light from an object. Marta-Navarro used computational techniques to analyze the spectrum of each and recover its star formation history by finding the best combination of stellar populations to fit the spectroscopic data. It tells you how much light is coming from stellar populations of different ages, he said. When he compared the star formation histories of galaxies with black holes of different masses, he found striking differences. These differences only correlated with black hole mass and not with galactic morphology, size, or other properties. For galaxies with the same mass of stars but different black hole mass in the center, those galaxies with bigger black holes were quenched earlier and faster than those with smaller black holes. So star formation lasted longer in those galaxies with smaller central black holes, Marta-Navarro said. Other researchers have looked for correlations between star formation and the luminosity of active galactic nuclei, without success. Marta-Navarro said that maybe because the timescales are so different, with star formation occurring over hundreds of millions of years, while outbursts from active galactic nuclei occur over shorter periods of time. A supermassive black hole is only luminous when it is actively gobbling up matter from its host's inner regions. Active galactic nuclei are highly variable and their properties depend on the size of the black hole, the rate of accretion of new material falling onto the black hole, and other factors. We used black hole mass as a proxy for the energy put into by the AGN, because accretion onto more massive black holes leads to more energetic feedback from active galactic nuclei, which would quench star formation faster, Marta-Navarro explained. The precise nature of the feedback from the black hole that quenches star formation remains uncertain, according to co-author Aaron Romanowski, an astronomer at San Jose State University and UC observatories. There are different ways a black hole can put energy out into, and theorists have all kinds of ideas about how quenching happens, but there's more work to be done to fit these new observations into the models, Romanowski said. Explore further expanding superbubble of gas detected around massive black holes in the early universe. More information. Ignacio Marta-Navarro al. Black hole regulated star formation in massive galaxies. Nature 2017. DOI 10.1038. Nature 24999.